Today, we're diving into a really fascinating story. It's a clash of ideas between a famous Hollywood actor and one of the world's best-known astrophysicists. And honestly, it's the perfect case study for understanding how science really works, and maybe more importantly, how you can tell the difference between an idea that's truly revolutionary and one that's just, well, flawed.
So how did this whole thing kick off? Well, the story really blew up just recently when the actor Terrence Howard called out Neil deGrasse Tyson on a massive podcast. But here's the thing, this isn't some new feud. This is just the latest chapter in a conversation that actually started 8 years ago.
So let's rewind the clock a little bit. What's the actual history behind this public call-out? And what's the deal with the document that started this whole thing in the first place?
Okay, so it all began 8 years back. Terrence Howard sends Neil deGrasse Tyson this 36-page document claiming he's basically reinvented math and physics. Now, you might think a guy like Tyson would just ignore it, right? But he didn't. He was actually intrigued by Howard's passion for the subject, so he sat down, read the whole thing, and gave him detailed feedback.
And that action right there brings us to a super important part of the scientific process. It's called peer review. You see, when a scientist is presented with a new, potentially world-changing idea, they don't just accept it, they test it, they scrutinize it.
Think of peer review as the ultimate quality control for science. It's where other experts in the field, his peers, come in and really kick the tires on a new idea. They're actively looking for calculation errors, flawed logic, anything that doesn't hold up. It's the system science uses to separate the genuine breakthroughs from the baloney.
And that is precisely what Neil deGrasse Tyson did. He treated Terrence Howard's work with the respect of a serious, critical review. He read it, analyzed it, and gave back some very blunt, very candid comments. You know, in science, that kind of direct honesty isn't an insult. It's actually a sign of respect for the effort someone put in.
But Tyson's feedback wasn't just about the science itself. He also pointed to a really common psychological trap that can catch any of us when we're diving into a new subject. It's called the Dunning-Kruger effect.
Have you ever learned just a little bit about something and suddenly felt like you've completely mastered it, like you've unlocked all its secrets? That is the Dunning-Kruger effect. It's that tricky phase where a little bit of knowledge makes you feel overconfident because you don't yet know enough to see just how much you don't know. This chart just illustrates the journey perfectly. Look at this. You start out as a novice, and your confidence skyrockets to the top of what's playfully called Mount Stupid. But then, as you learn more, your confidence plummets into the valley of despair. That's when you realize how complex the subject really is. But if you keep pushing through, you eventually climb out onto the plateau of sustainability, where your confidence is finally based on real, deep knowledge.
All right, so understanding that cognitive bias is really key here. It provides some important context. So, what were the actual scientific claims in Howard's paper? And how exactly did Tyson respond? Let's break down two of the biggest examples.
Okay, so one of Howard's core mathematical ideas was that multiplying a number by itself should always make it bigger. He even proposed that 1 times 1 should really equal 2. But as Tyson pointed out, there's a simple, fundamental flaw here. What about all the numbers between 0 and 1? If you take, say, 0.5 and you multiply it by itself, you get 0.25, a smaller number. And with that one example, something every middle schooler learns, the entire argument just kind of falls apart.
Then there was the physics experiment with a candle and a mirror. Howard claimed that this setup would double the amount of light you could measure. It seems intuitive, right? You see 2 flames. But Tyson brought it back to what's physically measurable. First, no mirror is 100% reflective, so you always lose some light. But more importantly, the reflection is farther away than the actual candle, and light intensity drops off dramatically with distance. So a light meter will always read less than double. It's not about what you think should happen, it's about what you can actually measure.
So if science seems so tough on new ideas, you might be wondering, how does anything new ever get discovered? How do we tell the difference between a crazy idea that's wrong and a crazy idea that's actually a genius breakthrough?
This is where Tyson makes such a crucial distinction. It's true that being a genius often means being misunderstood, at least at first. But, and this is the important part, being misunderstood does not automatically make you a genius. The difference is the evidence.
Just look at the theory of continental drift. When it was first proposed, scientists thought it was absolutely nuts. But then, the evidence started piling up. Matching fossils on different continents, coastlines that fit together like a puzzle. And then decades later, we literally mapped the seafloor and saw the mechanism in action. Science wasn't being closed-minded, it was just demanding proof. And that is the absolute beauty of the scientific method. Even the most out-there ideas can be put to the test. Einstein's theory of relativity was a wild idea, but it made a testable prediction: that starlight would bend around the sun during an eclipse. So in 1919, scientists went out, measured it, and proved him right. That is how a crazy idea becomes a scientific fact. It has to survive its encounter with reality.
And that leads us to Tyson's final and maybe most important point. If you really want to change the world with a new scientific idea, you don't go on a podcast, you submit it to a peer-reviewed journal. That's the arena. That's where your data, your methods, and your logic are put to the ultimate test by other experts. That is where the real work of science gets done.
So, what's the big takeaway here? In a world that is just overflowing with information, where anybody with a platform can present an idea as fact, this whole story is more relevant than ever. And it leaves us with a real challenge. How do you keep an open mind to new possibilities without letting your brain fall out? That's the critical balance we all have to find every single day.